Now I am going to discuss about self-excited DC generator. When the field winding is supplied from the armature of the generator itself, then it is said to be called as a self-excited generator. Based on how the field winding is connected to the armature to derive its excitation, this type is further divided into three types. One is a shunt generator, second one series generator, and the third one compound generator. If you consider the shunt generator, from the diagram you can observe that when the field winding is in parallel with the armature circuit and the combination is connected across the load, then the generator is said to be called as a shunt generator. Here, if you consider the field winding, the current passing through the field winding is indicated with ISH, the current passing through the load is indicated with IL, and the current passing through the armature is IA, and the voltage across the load is Vt, the terminal voltage. Here the field winding F1, F2 is represented as the field winding. It is having large number of turns of thin wire, so it has high resistance. So from the generator diagram you can observe that armature current is the summation of load current and ISH, shunt field current, whereas the ISH is nothing but Vt by RSH, and the induced EMF has to supply the voltage drop and the brush contact drop. So if you see the diagram, the armature current IA is a summation of IL and ISH. So ISH in turn is nothing but Vt by RSH. So the internally induced EMF E is supplying the voltage of the load. It is nothing but the terminal voltage. This is because when armature current IA flows through the armature winding, due to the armature resistance RA, there is a voltage drop across the armature winding which is equal to IaRa. The induced EMF has to supply this drop along with the terminal voltage Vt. So to keep IaRa drop to minimum, the resistance of the armature is designed to be very small. In addition to the IaRa drop as well as the terminal voltage, there is a brush contact drop which is nothing but the voltage at the brush contacts of the brush, but this drop is generally negligible. So the induced EMF has three components. First one is the terminal voltage, second one is the armature resistance drop, and third one is the brush contact drop. Now if you consider the series generator, in case of series generator, the field winding is connected in series with the armature winding while supplying the load, then the generator is series generator. If you see in the diagram itself, you can observe that the series field winding is connected in series with the armature. This combination is connected across the load. The field winding has less number of turns of thick cross-section wire, so it has very small resistance. So if you consider the current expression, armature current is the same current flowing through the field winding. So Ia is equal to If, which is the same current flowing through the load IL. So if you consider the voltage expression, the induced EMF is nothing but which is equal to Vt plus IaRa. An extra drop comes into existence, that is nothing but equal to IfRSC, where If in turn is equal to Ia. So IaRSC plus V brush. So the induced EMF is equal to Vt plus Ia into Ra plus RSC plus V brush. So if you come to the compound generator, the third one, in this type, the part of the field winding is connected in parallel with the armature winding and part in series with the armature. So both the series and shunt field windings are mounted on the same poles. Depending upon the connection of shunt and series field winding, compound generator is further classified as long shunt compound generator and short shunt compound generator. So if you consider the long shunt compound generator, the shunt field winding is connected across the series combination of the armature and series field winding if you observe in the diagram. So here the current relation, armature current is the same current flowing through the series field winding. So IA will be equal to ISC, and this is nothing but the summation of ISH and IL. So here once again the induced EMF, the expression for the voltage is nothing but equal to VT plus IaRa, the drop due to the armature, and IaRSC, the drop due to the series field winding. Next, if you consider the short shunt compound generator, in this type shunt field winding is connected only across the armature circuit, excluding the series field winding as shown in the figure. So the shunt field winding which is being connected across the armature, and this combination is connected in series with the series field winding. Therefore, the expression for armature current IA is equal to ISC plus ISH, where ISC is the same current flowing through the load, so ISC is equal to IL. So the induced EMF in the circuit is nothing but is equal to VT, the terminal voltage, plus IaRa, the drop in the armature, ISC-RSC, the drop in the series field winding, plus brush contact drop V brush. Thank you.